I want you to think of this conversion just like you would in a science class if you were converting from inches to centimeters. Okay, so we're converting from one unit of measure to the other. Here's how we do it. Let's start with degrees first and head into radians, which is another unit of measure. So 60 degrees, and I always rewrite them as a fraction because I like it to buddy up with my conversion factor and also be a fraction. So the conversion factor here is always going to be converting out of degrees and into radians. So we're converting out of degrees and into radians. So I'm going to multiply by pi over 180. I want to flip back for a second. I'm going to stop for a second and pause and flip back. Go back to the first page. Do you remember how we went around and we said what all these were? I'm going to pick a different color and I'm going to tell you what they are in radians so you can see how it matches up. So 0 is 0 is 0 all day long. If I go this far, this is pi over 2 radians. If I make half a revolution, it's pi radians. If I go this far, it's 3 pi over 2 radians. And if I make a full revolution, it's 2 pi radians. So that's how these things match up. So remember the fraction I just wrote? And I had pi and 180 together? That's because those are equal. So that's where that comes from. So I kind of wanted to just backtrack for a second and show you this so you understood where that all came from. Okay, let's go back now. All right. So the way that we deal with these is just a teensy bit different than what I'm going to do turning it into degrees in a minute. So remember with fractions, we multiply across the top. So I have 60 pi, and then you multiply across the bottom. 1 times 180 is 180. With these problems where we're converting to radians, we're going to reduce the fraction. So do you see how we still have a fraction here? That's often going to happen that you still have a fraction. So we need to reduce. What goes into both 60 and 180 evenly? 60, yeah. So let's divide both by 60. What is 60 divided by 60? 1 pi. So in the top I have 1 pi. What is 180 divided by 60? Nope. 3. So this would be pi over 3 radians. So that would be the conversion. So if I went back, you don't need to write radians. I will know it's radians if there is a pi. Okay. So yeah, I've been writing it just because I want you to get used to that word. Like I think I'm just trying to say that word more often, and so you get more comfortable with it because obviously like we're used to degrees. Yeah. So, okay, next one, same thing. Ooh, it's negative though. That's fine. Not much different than what we just did. Negative 160 over 1, so again I like to write it as a fraction as well, times pi over 180. So again, when you multiply across the top, you're going to get negative 160 pi, and when you multiply across the bottom, you get 180. Oops, I lost my one.
Wait, do we always use pi over 180?
Always.
Okay.
Every single time. If you're going into radians. So whatever you're going into needs to be in the numerator. Whatever you're coming out of needs to be in the denominator. So 180 degrees is denominator. Okay. Let's see. I don't even think I know for this one. What do we think? 20? What's going to work best? So I can divide both by 10, right? So basically I can kind of hack off the zeros. And then look at just your negative 16 and negative 18. What goes into both of those? Not 8. 2. How many times does 2 go into negative 16? Negative 8. So I have negative 8 pi over 18 divided by 2? 9. All right, I think 2 is good enough. We won't do 6. And I didn't save room for it anyways, so. Are we okay with both of those and reducing fractions? Let me show you a quick trick if you have a graphing calculator. Are you ready? Let's say you had, what did we just have? 160 over 180. I can type it in and hit enter. Do you see how it gives me the decimal equivalent? If you press math, do you see how it says frac? That is short for fraction. If you hit enter and hit enter again, it will give you the reduced fraction. Okay? All right, let's do 2 of the bottom ones now. Let's start with this one. 2 pi over 3 times. This time we are going out of radians. So this time my pi goes down here. And we are going into degrees, so this goes up here. So it's the same fraction, but it just flipped. It's the reciprocal. Ooh, I love that. What do we think? Do we think the pi's cancel out? Yeah. So that's nice. So I have 2 times 180, which is 360, over 3. Well, what is 360 divided by 3? 120. So these, you're going to give me a final answer where it's going to be a number or maybe even a decimal. These, you reduce the fraction. So it's kind of almost 2 separate rules. So up here, if you're going into radians, you're going to reduce the fraction. Down here, I'd rather have a decimal. Okay, let's try the next one. Actually, we'll just do all 3 for this one because they're all a little different. Again, I'm going to make it a fraction by putting it over 1. All right, what happens with the pi's? They cancel. And 7 times 100 and, oh, okay. 7 times 180 is? Yeah, 1,260, and you can use your calculator, obviously, for any of this. Okay, so that's that one. Let's do the last one. Negative pi over 12. What should I multiply by? 180 over pi. What happens to my pi's? They cancel. So I have negative 180 over 12. And this one I'm going to actually divide it and give the answer. Oh, I thought it might be a decimal, but no, it was lovely. It is negative 15 degrees. So again, you might want to write yourself a little reminder note that up here we are reducing the fraction. Down here, I would please like decimal answers. Okay, so that might be a nice little note to remind yourself. And again, remember that your conversion is the fact that pi radians is equal to 180 degrees. So you're using either pi over 180 or 180 over pi. Are we ready for homework?
Yes.
Yeah, I don't think today is a bad day. All right, thought it was fairly simple. Okay, homework tonight, and for the couple of you who didn't finish last night, you have a lot of time and you might find that you can do tonight's homework and then also last night's. Assignment number 2, page 561 to 562, numbers 34 to 39 and 43 to 48. Questions?